Mars has never felt a human step. Its dust has never shifted beneath a living footprint. Yet the planet is already part of our story. For more than half a century, we have crossed the void to reach it, sending machines that descend in fire, unfold in silence, and begin studying a world older than memory. These machines carry the imprint of Earth, every panel assembled by living hands, every circuit built in laboratories designed to keep biology out, yet engineered by biology itself. Sterilization reduces risk. It never erases it. Some microorganisms endure conditions that rival Mars: radiation, desiccation, cold measured in geological patience. Mars appears barren: thin air, oxidized soil, endless deserts of iron dust. And yet, beneath its surface lie fractures of ancient rock, traces of long-vanished water, chemical gradients that once approached the edge of life. If even the faintest biological potential still lingers there, dormant, microscopic, woven into mineral pores, our presence has already altered the equation. Exploration reshapes what it touches. Curiosity moves matter. It transfers heat. It carries molecules across worlds. Mars remains vast, ancient, indifferent, but it is no longer isolated. And the difference between observation and interference is thinner than the atmosphere above its plains. For more than half a century, Mars has not been alone. Since the 1960s, we have been sending machines across interplanetary space: orbiters, landers, rovers. Some failed, some crashed, some still move across its deserts today. More than 50 missions have attempted to reach the Red Planet. Each one carried instruments, cameras, drills, spectrometers, and heat. Entry vehicles sliced through the atmosphere at thousands of kilometers per hour, compressing and igniting the thin Martian air. Parachutes deployed, retro rockets fired. Each landing disturbed soil that had not been touched for billions of years. Dust was lifted, regolith displaced, subsurface layers briefly exposed. It seems insignificant, a few square meters on a planet the size of a continent. But Mars does not have oceans to absorb change. It does not have thick air to dilute contamination. Its atmosphere is thin, its surface chemically reactive. Its ecosystems, if they ever existed, would be fragile beyond comparison. Every spacecraft that lands transfers energy into that system: heat from engines, radiation from electronics, chemical residues from fuel and materials. We call it exploration. In physical terms, it is interaction. Mars is still vast, still ancient, still overwhelmingly indifferent, but it is no longer untouched by Earth. We build spacecraft in rooms cleaner than operating theaters, air-filtered, surfaces sterilized, and still, sterility is never absolute. Life persists. It survives radiation, dehydration, cold measured in geological time. It waits. When a spacecraft leaves Earth, it may carry more than instruments: resistant spores, shielded cells, fragments of DNA. Most will die, not all must. Mars seems barren: thin air, oxidized dust, frozen ground. Yet beneath its surface lie ice, brine, chemical gradients once close to life. Planetary protection exists for one reason: to preserve a question. If life ever emerged on Mars, we want to find it as it was, not as we changed it. Because if Earth microbes adapt and replicate there, we may detect biology, and never know whether we discovered a second Genesis or only ourselves. And that difference is smaller than a grain of dust. For decades, we have asked how to reach Mars. Now a different question emerges: what happens when we decide to stay? Terraforming is often described as engineering, a technical challenge, a matter of atmosphere, pressure, temperature. Thicken the air. Release carbon dioxide from the poles. Warm the surface. In theory, the process is simple. In reality, it means altering an entire planet. Mars is cold because it lost its magnetic field. Its atmosphere is thin because solar wind stripped it away. To make it warm and wet again, we would have to override billions of years of planetary history. Artificial mirrors in orbit, nuclear detonations at the poles, massive greenhouse gas production. Each proposal carries consequences. A thicker atmosphere would trap heat, but it would also trap whatever chemistry already exists beneath the surface. If native microbial life survives in hidden niches, terraforming could extinguish it or force it to compete with Earth biology. The question is no longer scientific, it becomes ethical. Does a planet without intelligent life belong to the first civilization that reaches it? Or does it possess intrinsic value, independent of our ambitions? Exploration changes worlds, colonization transforms them, and transformation is never neutral. Mars is not just a destination, it is a mirror. Every question we ask about it eventually turns back toward us. Can we survive there? Should we change it? Do we have the right? For the first time in history, a single species has gained the power to alter an entire world. Not through accident, not through evolution, but through intention. We often imagine terraforming as an act of creation, but creation always replaces something, even silence. If Mars is empty, then it becomes our responsibility. If Mars is not empty, then it becomes our restraint. The difference between those two futures may depend on choices made long before the first city is built. Exploration begins with curiosity. Civilization begins with power. And wisdom begins when we understand the cost of both.